All right, Mr. Ahmed here, moving on to 5.2. Today we are going to work with congruent polygons, mostly with congruent triangles. The reason why we're saying polygons, well, triangles are polygons, so we're going to take a look at some four-sided and five-sided figures as well. So, first thing, we're just going to define this more specifically with congruent triangles, but the same thing applies with congruent polygons, all right? So, congruent triangles occur when all of the parts of one triangle are congruent to all of the corresponding parts of the other triangle. So, when we talk about a triangle, it has more than 3 parts. It has 6 parts. It has 3 sides and it has 3 angles. So, for triangles to be congruent, that means 6 things are going to be congruent between those 2 figures. All 3 sides and all 3 angles. Okay? So, when I look at this diagram here, triangle ABC has sides of 3, 4, and 5. XYZ also has sides of 3, 4, and 5. And then when I look at the angles, I see a 90, a 90, all right, a 53, a 53, a 37, and a 37. So we have 3 congruent angle pairs and 3 congruent pairs of sides. All right, so the corresponding parts in these congruent triangles are the corresponding sides and the corresponding angles. So the first thing we're going to do is list out all the corresponding sides. So when I look at side AB, AB is 3. So AB is congruent and it corresponds with XY because those are both 3 units. So that's one pair of the corresponding sides. BC is 4, YZ is 4. And notice I'm putting segment signs above because we're using a congruent sign. And lastly, side AC is congruent to side XZ. So those are corresponding sides. The corresponding angles are the congruent angles. So angle B corresponds with Y. Angle A and X. And lastly, angle C and Z. So, 3 pairs of corresponding / congruent angles, 3 pairs of corresponding congruent sides. So, the triangle congruent statement is what we use when we name the 2 congruent triangles. Now, here's the tricky piece of this statement. The corresponding parts need to go in the same order. So, when I name the first triangle, I name it by its vertices. So, I'm going to name the first triangle, triangle ABC. And we would state that it is congruent to triangle. We have to put the parts in the same order. So A corresponded with X. So since I put A first, I also need to put X first. And then I went to B. Angle B corresponds with Y, so Y needs to go second. And C corresponded with Z, so Z would have to go last. So all of the corresponding parts are located in the same statement or in the same position when I name this congruent statement. All right? So this is vital. These parts need to go in the correct order because I can use this statement without a picture to determine which parts are congruent. So just based by looking at this statement, I know angle B is congruent to Y because they're in the same location. C is congruent to Z, those 2 angles. I also know that segment BC is congruent to segment YZ because they are in the last 2 slots. AB is congruent to XY. They're in the first 2 slots. So I can use that statement to figure out all of the congruent parts. So that's what we're going to do in the first example. So I have 2 congruent triangles. Notice they are not drawn the same way. All right. So we have to use this statement to figure out which parts are congruent. So the thing that I see first is T has to be congruent to P, J is congruent to H, and angle M is congruent to angle S. The angles are each letters. So we have an angle T, an angle J, and an angle M, just as it states, an angle P, an angle H, and an angle S. Okay, then the sides are 2 of them. So TJ is a side. There's TJ. JM is a side, etc. So, let's see here. It says first, angle P is congruent to which angle? So I just have to use a statement. P is in the first slot, T is in the first slot. Those are congruent. So angle P and T are congruent. So that means if T is 73, P also has to be 73. So I'm going to put that in now. All right, question 3 says JM is congruent to what? So JM, that's the last two letters. HS is the last two letters, so it's congruent to HS. So I'm going to mark JM and HS with a tick mark. JM, HS. So those two are right next to each other. Okay. Next, it says find the measure of angle M. So since it's an equal sign means I need a value. So I have to figure out what angle M is. So let's see. M is congruent to S. S is 48. That means M is also 48. So this is 48 degrees. Now notice, the first one, I put angle because an angle is congruent to an angle. This has an equal sign for number 4. So with the equal sign, I actually have to figure out the value. What's it equal to? Same thing with 5. It says, what's angle P equal to? So we need the value. P we already labeled is 73. All right, next thing says to find MT is equal to. Again, equal to sign means a number. Congruent sign means a segment. So in number 3, we named the segment because it was congruent. Number 6 is an equal sign, so I have to actually find what's it equal to. What's its length? So MT is the first and last. SP is the first and last. So SP is 5. Put 2 tick marks there because we already used 1. So SP is equal to MT. So 5 and 5. So this one's 5. All right, now it wants me to switch the order of the statement. So this one's named HPS. So when I look at the statement HPS, for me to keep the corresponding parts in the same location, H corresponds with J. So J would have to come first. P corresponds with T, so T in the middle. And S corresponds with M. M is last, so it has to be triangle JTM. So when you work on these problems, equal signs, you have to find values. Congruent signs, you're naming the congruent parts. All right, now here's our four-sided figure. In a similar manner, when we use this four-sided figure, we have to use the statement to know which parts are congruent, which parts are equal, okay? So I know that angle D is congruent to S, E is congruent to P, F is congruent to Q, G is congruent to R, etc. So first thing says find X. So where's my X? X appears to be this side QR. So QR has to be equal to FG. So I know FG is 12. That means these two are congruent. So 12 is equal to 2x minus 4. Now I can solve that. 16 equals 2x. X is equal to 8. So x is equal to 8. And now we got to locate our y. See a y here. Also has an x, so it's an angle. Angle Q and angle F are congruent. F is 68. Q is also 68. So when I set up this equation, I'm going to say that 68 is equal to 6y plus x. Oh boy, that has two variables. But wait, we already found x, so I can put 8 in. So 68 is equal to 6y plus 8. Substitute it in. Subtract, and we get 60 equals 6y, and y is equal to 10. So you will have to use some four-sided figures for this process. All right, our next example. We are going to use the statement to name all of the corresponding parts, and then we'll find the value of x and the measure of angle G. So first thing, let's do the angles over here and the sides over here. So angles. Angle Q is congruent to angle G. R and H and S and K. Corresponding locations, okay? Q first, G first. R in the middle, H in the middle. Now the segments. QR, the first two letters, is congruent to GH, the first two letters. RS, the last two, is congruent to HK, the last two. And now the outer two, QS, is congruent to GK. And we've named all the corresponding parts. Now it says find the value of X. So G, let's see here. G is congruent to Q. So G and Q, oh boy. I don't even know what Q is, but I think I can find it. These three have to add up to 180. So for me to find Q, I'll take 180 minus 50 minus 42. So Q is 88 degrees. That's a pretty bad 8. I can make that let's just scratch that off. 88 degrees. So we found Q. So now I would say that 88 is equal to 2x minus 7. And then when I solve, add 7. And we get 95 equals 2x. 95 divided by 2 is 47.5. So I can get a decimal. Decimals do exist. And lastly, it said to find the measure of angle G. Well, we already found G. G was the same as Q, so the measure of angle G is equal to 88 degrees. So we got that as well. All right, a little exploration here. Okay, we're getting close. If a triangle has an angle that's 82, so let's just say this one here is 82 degrees, and another that's 50 degrees, what does the third angle have to be? So what's this one? Question mark. Well, I just have to subtract from 180, right? So I would take 180 minus 82 minus 50, and we get 48 degrees. Now, if a different triangle has those same measures, one of the angles 50 and the other's 82, what does the third one have to be? Well, they all have to add up to 180 just like they did in this one, so it also has to be 48 degrees. So that leads us to our theorem of the day, and that's called the third angles theorem. And it just states that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So in this diagram, B is congruent to E, A is congruent to D. So angle C has to be congruent to angle F. All three angles have to be congruent. Now notice, I put 3 tick marks down for this because all the angles aren't necessarily the same size, okay? So that's a handy theorem, kind of logical, makes sense, super easy to prove. So just 2 more examples here of finding the missing sides or missing angles. I have a 90 degree, look for the right angle marks, 41 and X. For me to find X, well, X plus 90 plus 41 has to equal 180 because this is a triangle. It is a 3-sided figure. This whole half over here didn't even matter, didn't even know it. So I can just solve there. So 90 plus 41 is 131. Subtract our 131. And we get 49. So just a couple things here. This was 49. And this is also 49. Notice this triangle, 2 congruent sides, isosceles, that's going to come up. Okay, last one, the bow tie again, vertical angles. Got to see those vertical angles. All right, 47, 47. These are marked as congruent. We're supposed to find angle D. So if I have these 2 angles being congruent, 47 congruent, 47 congruent, that means that these third angles have to also be congruent. So angle C has to be 71. And then I can find the missing one by taking 180 minus 71 minus 47. So we used that third angle theorem there to figure out that angle C was 71. All right, so 180 minus 71 minus 47 is 62. So the measure of angle D is equal to 62 degrees. We got it. So this was a little bit of a trickier one. You'll see a few of them as well. Have a good day.